So first of all, I want to thank everybody for taking time out of their busy schedule to take part in this webinar. We've had some very, very, very good feedback over the years about it. Obviously, as things change, we go through an update. But one of the things that I did get chastised about last time that I did this webinar was that we had recently had a change to the ASTM standard, and I didn't make a big deal about it. So I want to make sure that for those of you that are familiar with the ASTM F2170 standard, that you know that as of about probably 4 weeks ago, the standard has been changed. It used to require a 72-hour testing period. So you had you drilled the hole, you did all the things that you had to do, you set the test, you had to wait 72 hours before you had a documentable result. As of about 4 weeks ago, that standard has now officially been changed and is in documentation under ASTM F2170-18, where it says that you only are required to leave the test or have that testing period be 24 hours to deem it official. So I want to make sure, first and foremost, I throw that out there so that everybody is completely aware. The great thing about that is it really does cut back 24 or 48 hours based on what we used to have. And if you compare it to anybody who's actually doing any type of calcium chloride testing, you're looking at 24 hours versus a 60 to 72 hour window that you require with calcium chloride. Second thing is, this is my shameless promotional 30 seconds, but we have a device that we just launched yesterday that's called the Wagner Meters Smart Logger, and it's a Bluetooth data logging device for ambient relative humidity and temperature. And as a lot of you know, knowing and being able to document ambient conditions within the environment where you're doing concrete moisture testing is very, very, very critical. And this device helps you to do it to ensure that you have the documentation you need to be able to have with your moisture testing results. So get through that. My name, for those of you that don't know, is Jason Spangler. I'm the flooring division manager here at Wagner Meters. My responsibility is not only the concrete moisture testing side of things and the Rapid RH, but I'm also responsible for the small line of hand meters that we have for testing the moisture content of wood, finished wood products, finished wood floors, and subfloors. We're going to do a Q&A here. If you have any questions, please send them to me. If for whatever reason I don't get to them, feel free to give me a call directly at 800-634-9961 extension 235. So with that, I'll get to the first question. Looks like I have one that came from David. It says the instructions with my kit say install the sensor and sleeve, then remove the sensor from the sleeve, let it equilibrate for 3 days, and then return, replace sensor and sleeve, and take the measurements. The webinar suggests that we will get readings the same day. Do I need to wait 3 days? My guess is, with what you're looking at, is that you're still looking at the old standard or the documentation that we have that has not been, you know, whenever you bought the kit hadn't been changed. This is all very fresh. So, and it looks like that you're probably also dealing with our 5.0 system, not our 4.0 system, where you have the removability of the sensor. So the answer to your question is, letter of the law with the ASTM standard, no matter whose device you're using, drill the hole, sleeve it with the sensor or without the sensor, leave it for 24 hours, come back, get the reading, that is your number. If you are not leaving the sensor in there the entire 24-hour period, the standard says that you have to take the sensor, put it into the environment after the 24 hours, take a reading, wait 5 minutes, take another reading, and it can't move more than 1% variance up or down on the relative humidity, so that you know that that sensor itself that you've now put in there has acclimated to that environment. It's come from the normal ambient conditions and now it's going into a higher relative humidity environment. It takes time for it to acclimate. So you know that it's acclimated if you have a change in your rate of change in a 5-minute period is less than 1%. Questions that I get a lot. Thickness of the concrete. Obviously, everything in this webinar talks about depth-specific measurements and the fact that they're critical. How do I know that if I can't determine the thickness of the concrete, or how do I determine the thickness of the concrete? Couple of things. If you're not used to looking at the thickness of the concrete or trying to determine the thickness of the concrete, I always tell people to be surprised when it's in the forefront of your mind how often you go out on a job site and you can see things. You can see slab on grade. They're doing trenching on a rehab job. Maybe you're out there earlier when they're still pouring a small section, and you can see what the specified thickness is. Elevated slabs, penetrations that come through the pan decking or come through the structural slab, most of the time are not going to be cut to fit. There's going to be some kind of room around them, so you can look down in that room and be able to see what it is. Stairwells. Sometimes you see have indication in the stairwells when you have multiple floor projects. Worst case scenario, there's a couple of different options. One is there is a device out there that does work off of what they call echo impact principle. It is something where you can put it on the surface of the concrete. It works in conjunction with a smart device, iPad, iPhone, Android device. But it plugs into it, and what it does is it gives you a very close approximation to what the thickness of the concrete is. That's the positive side. Negative side is, last time I checked, it was about $2,500. So for most people that aren't doing these types of testing all the time, it's extremely difficult to justify that price. On the other side is, I hear a lot of people will actually drill smaller diameter drill bit or the smaller diameter holes in the slab. And again, not saying to turn the slab into Swiss cheese. You're not putting holes all over the place, but a couple of strategically placed holes to have comparative information. You can take a piece of wire and put it down in the hole, put a J in it. As you push it down, J springs out. You can pull it up. When there's resistance on it, you're at the bottom of that wire. Take a Sharpie, mark it off. As you pull it out, you can see where the radius of the wire is compared to the Sharpie mark, and it gives you a close approximation. Again, at that point, you've done your due diligence. The other question I get a lot is about pan decking. Where do I place the sensors? Am I calculating my 40% based off the thin part of the pan decking or the thick part of the pan decking? And then with that, if we're going off the thick part, how do I identify the differences or identify those different areas within the slab? There are some people that have ground penetrating radar that is at their disposal, that they can identify where those undulations are or those variances are with the pan decking. But I'll back up. The ASTM standard is completely silent on whether you're calculating or placing the sensor in the thick part or the thin part. We as a company, we recommend that you calculate based on the thickest part of the pan decking, and that you install in that thickest part of the pan decking to give you the best representation of the entire slab. With that, you need to identify that thick section of the pan. And so, again, the ground penetrating radar, we have some people that will, based on a general idea of where the pan decking is, or that they can tell where the fluting is, they will drill holes to try to identify where the thickest area is. Again, smaller diameter holes, but you're trying to figure out exactly where you're at. Worst case scenario, or that's worst case scenario. The other side is we have people that will buy a fairly inexpensive metal detector that works a lot like a wood stud finder for a wall, but it's flat and you scan across, and the scan in it is strong enough that it will pick up the high parts of the metal in the pan decking, but not so strong that it picks up the low parts. So you can scan across, pick up your hi-hat, scan across again, pick up your next hi-hat, and you know that you're in the middle of that. Is it perfect? No. Is it going to pick it up every single time? No. Does it take a little bit to be able to understand it and see when it is being consistent? Yes. But for under $100, you can have a device like that, and it's something that does at least help you or give you a place to start. So it doesn't look like I have any other questions. Again, my name is Jason Spangler, and my phone number is 800-634-9961, extension 235. And if you have any questions at all, that's what we're here for. Give us a call. Thanks, and have a great day.